starting with number 5 on 7.SP.7a. What's the probability of rolling a number that is greater than 4 on a number cube? Alright, so on a number cube we know that there are 6 possible options. And those are 1, 2, 3, 4, 5, and 6. Those are the possible options. We want a number that is greater than 4. So we want a number that's greater than 4. There are 2 out of 6 that are greater than 4. We need to simplify that. Divide them both by 2. 2 divided by 2 is 1. And 6 divided by 2 is 3. So the answer to 5 is B. On to number 6. Consider a set of cards where each card is printed with a letter of the English alphabet. Each letter in the alphabet has its own card. The cards are placed into a hat. What's the probability of randomly selecting a card that is printed with a vowel? Okay, so we need to know how many letters are in the English alphabet. I mean, you could count A, B, C, D, E, F, G. You can keep going. Or you can know that there are 26 cards in the alphabet. Out of those 26, what's the probability? So the numerator is going to be that it is a vowel. And how many vowels are there? A, E, I, O, U. 1, 2, 3, 4, 5. 5 out of 26. Can we simplify this? Nope. So the answer to 6 is B. Moving on to 7. A role-playing game die has 12 faces numbered 1 through 12. Each face is equally likely to appear on top after a roll. Which of the following events has a probability that is less than the probability of rolling a prime number? Okay, so what is the probability of rolling a prime number? There are 12 numbers, so let's write those out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Now which of those are prime? 1 is not prime, so let's circle the prime ones. 2 is prime. 3 is prime. And a prime number is a number that can only be divided by 1 in itself as a whole number. 5 is prime. 6 is not. 7 is prime. 8, 9, and 10 are not, but 11 is. So out of these 12, 1, 2, 3, 4, 5. 5 of them are prime. So this is the probability of rolling a prime number. So let's look at A. What's the probability of rolling an even number? So out of these 12, and since we're comparing, we're going to keep the denominator as 12. The probability of rolling an even number. How many of them are even? 2, 4, 6, 8, 10, and 12. That would be 6 out of 12. So that does not work. Moving on to B. The probability of rolling an odd number. Well, that is also 6 out of 12, so that one does not work either. The probability of rolling a multiple of 3. So out of 12, how many of them are multiples of 3? Well, the first multiple of 3 is 3, and then we have 6, then we have 9, and then we have 12. And there are 1, 2, 3, 4 out of 12 options. We're looking for a probability that is less than the probability of rolling a prime number. This is less. C is our answer, but let's find the probability for D. Probability of rolling a number greater than 2. So out of 12, how many are greater than 2? Well, all but 2, so 10 out of 12. That is greater, and we're not looking for that, so D cannot be our answer.